Rotation about an arbitrary point. Rotation about an arbitrary point. See, previously we have considered the rotation according to or occurring with its origin, about the origin. Means if a line is there and we rotate it, then it is rotate about the origin. Origin remains, after the rotation, origin remains same. Homogeneous coordinate provide a mechanism for rotation about points other than the origin. We can rotate it other than the origin. It is possible with the help of homogeneous coordinate. For that, there are three steps we need to apply. What is the first step? Set the point first. Translate the point or the object to the origin. This point, arbitrary point, we are moving it. The rotating about an arbitrary point other than the origin, correct? So this point first we need to translate to the origin. Then perform the required rotation, whatever the given. It may be any angle theta or it may be the standard angle 90 degree, 180 degree, etc. Perform the required rotation. And then whatever the result, translate it back to the original center of the rotation. Now means thus the rotation of position vector xy1 about the point mn. Mn is the point through which we are going to rotate, not through the origin. Can be, for that I write here the transformation matrix. So the rotation of position vector xy1. See, this position vector, it may be point, it may be line, it may be triangle, it may be square, it may be rectangle, anything, anyone you can consider. xy1 about the point mn. We are rotating through some arbitrary point, not through the origin. So that point is mn with some angle. With angle theta. So I write here our new position vector. The result is x star y star 1 is xy1 original position vector multiply with the transformation matrix. Now here three steps are there. So we require three transformation matrix. First, for translate the point to the origin. If is not with the origin, translate it to the origin, that point mn. Then perform the required rotation, means require the second transformation matrix, and the third one is translate result back to the original center of the rotation. So first translate the point to the origin. The point is mn. So for translation we use the translation matrix, this one, correct? So tx and ty, at that position tx and Ty, what we are going to use? M and N. Okay, M and N to the origin. For that we require minus M and minus N. We see it with example. Only remember that first we are translating the point M N to the origin. That's why we use Tx and Ty as minus M and minus N. This 0, 1, 0. At Tx and Ty, I write here minus M and minus N and 1. Minus M and minus N and 1. So this is the first transformation matrix. Translate the point to the origin. Then the next, rotate it with the given angle. So the rotation, for rotation, the transformation matrix is cos theta, sin theta, minus sin theta, cos theta. Correct? That is also here. The rotation, this one we are using. Okay, we are using this one, cos theta, sin theta, minus sin theta, cos theta. And the last transformation matrix, it is for translate the result back to the original center of the rotation. Means this Mn, this point, we translate it towards the origin. Now we translate it back to the original position. So for that, again we require the translation matrix along with plus M and plus N. Along with plus M and plus N. So that is our first step, or the transformation matrix for first step. This is the transformation matrix for second step, and this is the transformation matrix for the third step. Now we try to simplify it. The position vector may be anything: line, triangle, rectangle, square, etc. After multiplication of all these things, cos theta minus sin theta, this multiplication already I have done, minus M cos theta minus 1 plus N sin theta, sin theta cos theta minus N cos theta minus 1 minus M sin theta. Okay. So after multiplying the original position vector with this transformation matrix, we will get the result. The result, rotation about an arbitrary point. Now see the example for this. Suppose that the center of the origin is the center of an object is at 4, 3. Means M is equal to 4 and N is equal to 3. We need to move towards the origin. Now the center of the object is 4, 3. Now we need to move towards the origin first. And it is desired to rotate about 90 degree, standard degree counterclockwise. So the three steps we need to do here. What is the first step? The translate the object or the point 4, 3 towards the origin. For that, the first transformation matrix T is equal to -4, -3, 1. Minus m and minus n means translate the point towards the origin. After that, the second rotate it about an angle 90 degree. So standard rotation is there, not necessary to use cos theta, sin theta. For rotation through 90 degree, 0, 1, -1, 0. The remaining are homogeneous coordinates. So that is the second step transformation matrix 90 degree. And the third step, translate the result back to the center of the object. Where is the center of the object? 4 and 3. So we need to translate it back. So the third transformation matrix that we required is 1, 0, 0, 0, 1, 0 plus 4 plus 3. Okay. Now apply all these steps. There are two ways. You can apply all these steps one by one. First, perform the first transformation, translation with first transformation matrix. Then the result multiply with this one. Then that result multiply with this one. That is the one step. Another step is that you can perform all these multiplication together. So the entire operation is the original vectors, position vectors, and the first one 1 0 0 0 1 0 -4 -3 1. Second multiplication transformation matrix, and the third. We can combine these three and multiply it with the original position vectors. These calculations I have done already. That's why I am writing it directly. But when you are doing, you need to multiply it. So that is the entire transformation matrix. And multiply it with the original position vector, you will get the result that rotation about an arbitrary point. Example, consider rotation of land line. Consider rotation of line AB about point with A as 2 2 and B as 5 5. About point about an arbitrary point 1 1 through 90 degree. Suppose we want to do it. The point is given, a line is given, we want to rotate this line about an point 1 1 through 90 degree, not through the origin. Here we require the three transformation matrix. I write it directly. The final result x t X star is equal to X multiplied with T. What is here X? It is AB. Now, here the transformation matrix is 3 into 3. So, we need to add here. In this way, you can add. The last point, it is 0, 0. Multiply it with the first transformation matrix. Minus m minus n. Minus 1 minus 1. Second transformation matrix, rotate it through the 90 degree. 0, 1, minus 1, 0. And the third transformation matrix, this is minus m minus n. This is plus m plus n. And this is for 90 degree. Try to multiply it. I draw it here so that you can understood the actual what happens. What is the line? Original line 2, 2. It is here. AB 5, 5. B is here. A is here. So that is our original line. First, if we perform the first test, then translate it and then rotate. And then this one. What is the result? See, if you perform one by one, then you can observe the result here. Okay. First, multiply the line AB with the first transformation matrix or translation, that is minus 1 minus n. The first step we will do here, multiply with the first one. 1 0 0 0 1 0 minus 1 minus 1 0. First step. What is the result? Same. 1 1 4 4. It is 1 1. It is 4 4. Somewhere here. Okay. So it is translated towards the origin. Now the second step. This result multiply with the rotation. The rotation transformation matrix 0 1 0 minus 1 0 0 0 0 1 for 90 degree. That is rotation. The result is minus 1 1. minus 1 1, where it is minus 1, I write here minus 1, minus 2, minus 3, minus 4, minus 5. So minus 1 1, it is somewhere here, and minus 4 4. So this line is rotated 90 degree. Okay, it is rotated 90 degree. Check. So you can observe that this line, this AB blue line, it is first translated toward the origin. Now it is rotated to the 90 degree, and the last step is again back to the original position. So this result, multiply it with the last one. The 0 to this one. This is the final result, A star 0 2 and minus 3 5, B star, in this way. The final result. See once again, first this original blue line AB, here we translate it to the origin to using the point minus 1 minus 1, then rotate it with the 90 degree, rotate it with the 90 degree, and then translate it to the original position plus 1 plus 1. Then we will get the final result. A star B star is the pink line I have drawn here with the pink line.